Hi, my name is Mira Kuntuala, and this is my exam wrapper for the second test. I chose to do problem 3 because that's the question I got the most off on, and the one that I was kind of the most confused about, and now that I understand it, I want to explain it. So for part A, we have 2 electrons, and as soon as I read 2 electrons, I immediately thought like repulsive force, and for repulsive force, kinetic energy and potential energy have certain shapes that they have to be, and it says that would start off at some distance apart and at rest, which means their initial velocities are 0. So knowing that their initial velocities are 0, I knew that kinetic energy had to start at 0. So the kinetic energy starts at 0 at location R initial, so it doesn't start at the origin because they start some distance apart. And then for repulsive forces, kinetic energy goes up in this fashion, and kinetic energy can never be negative. So the graph starts here at a value of 0 and then goes up. And then potential energy for repulsive forces is positive and it's decreasing, which contrasts for attractive forces, which is like a shape this way underneath the x-axis. And then when you add up the kinetic and potential energies, the total energy is going to be a straight line that's constant above both of those graphs. So then next for part B right here, it says a comet approaches the sun from far away but does not collide with or orbit the sun. So for this, we know that it's unbound motion, and the potential energy follows the gravitational potential energy, which is in this shape, that comes close to the origin or come close to the x-axis but never touches it. And then the kinetic energy is going to lie above the energy line right here, because adding the negative potential energy to the positive kinetic will yield something in the middle right here, which is the total energy. And then for the third part, a spacecraft leaves Mars with an initial velocity that is below the escape speed for Mars. So we know that there is a value of closest approach right here, which is a final kinetic energy, and then we know that there's an initial starting point for potential and kinetic energies, and that we know that it limits the energy right here. So the energy line doesn't go all the way straight and is continuous. It only is going to lie in the plane of where the kinetic energy is, because if there's no kinetic energy, then there's no total energy that needs to be that goes any further than that. And then again, the potential energy matches what the gravitational potential energy should be, which is this shape, and that's about it for problem 3.